In this one, we're going to be covering functions. And functions are very helpful whenever we have code that we need to have happen many times over, uh, especially if we find ourselves copying and pasting that code a lot. So you might say, well, if we want to do something over and over again, why not use a loop? Sometimes a loop is the optimal way of doing something, but other times, especially when our code gets a lot longer or our programs get more complicated, using functions simplifies our code greatly, and it makes it where we can access that code over and over again in a very efficient way. And so I'm going to introduce you to the syntax for a function here, and that is def. This is defining a function. Whenever we define a function, we're saying to the program, we have this function here with some name, and it does this. And that's all we're saying when we define it. When we define it, we're not executing it. Executing it or calling it will come later. But when we define it, this code is not being run. It's just saying, hey, Python interpreter, I have this function here. It does this, but I'm not using it yet. So it's very important to have that distinction. So let's say we want to have a function, and let's say that we want it to add two numbers together. So I'll call this add. And then you have to put a colon at the end because it's a statement. All right, after this, we have this little part with the parentheses here. We have to define what type of input it's going to take. And so I'm going to say it's going to take A and B. Because when you think about addition, you have to have two numbers to add. You have the plus, a number on the left, a number on the right, and that's your addition. So we have to have these two input parameters so that we know what we're adding. Now I can come down here. Notice this is tabbed over, which is saying that we're inside of this function here. We're inside this function definition. And so I can declare a variable. I'll say sum is equal to A plus B. And the values of A plus B, we don't need to know them because we'll let that be handled later on. We'll let whoever uses this function later tell us what A and B are going to be. At the end of this, we have to return a value, which is to say, once this function is done, we have a specific value that when this function is done executing, we leave that value there to be used for later. But everything else inside the function is destroyed. It's forgotten. So I'm going to say return to get that value. I'm going to say sum. So this is a function definition, a very simple one. And this code is not actually executing. And it's because this is just the definition of it. To use the function, I'll come down here and I'll say add. Let's say I want to add 3 and 7. And so in order for me to see what this is doing, I'll print this out. I'll pause there for a second so you can look at what I have. I have the definition of an add function. It takes in two numbers, A and B, and then it adds A and B together and stores that into a new variable sum, and then it returns sum. This returns sum on line 3, that's saying that when this part right here, this add 3, 7 part is done executing, replace this code right here that's highlighted with whatever value is in sum. In this case, that should hopefully be 10. So we'll jump over to our command line, clear it out. And we'll do functions, run that, and we get 10 up here in the top right. And so our add function is working correctly. If I change this to a -3, -3 plus +7, it's a +4. And so if I save that and run it, we get +4. And that's all there really is to functions. They have this keyword def, give it a name, and then you define the input parameters, which is everything in the parentheses here, and you put a colon at the end of that. Then you tell the function what to do. At the end of the function, you will return some value, which is to say, when it's called, like here on line 5, this is replaced with whatever the function finds your return value to be. And so whenever we call a function, it's the syntax of the name, followed by an open parenthesis, and then we list the parameters that we have to put in there. Then we close that parenthesis. Let's watch what happens if I take off one of these input parameters. If I take off 7, I just leave it with -3. This should give me an error. It says type error, add missing one required positional argument. Positional argument is saying you forgot to put one of your inputs in there. It says one of them is missing. Okay, so this is the basic way that you define a function. And I'm going to fix this real quick, put that 7 back there so I don't get that error. This code will run now without errors if you want to put this down to your notes, if you're taking notes. I'm going to give you an assignment, and that is to finish out implementation for not only addition, but subtraction, multiplication, and division. And this is going to be one of those projects where I'll post the solution to it because it can be conceptually hard to think about depending on where you're at. But I would like for you to implement subtraction, multiplication, division with only using the plus sign or calling your earlier functions. And also, you can use this negative symbol, but only as negation, not as subtraction. So I'll go ahead and give you subtraction, how I'd like this to be implemented. I'll say def, def for defining a function. I'll say sub for subtraction. I'll put a and b. And then I'll say I'll say difference, diff, is equal to a plus negative b. I'll return diff for difference. Now, I could have just said a minus b, like this, but this assignment I'm giving you is called Everything is Addition, and we're going to be implementing everything just using addition, as in the only built-in addition symbol we use is this one right here, and we don't use the negative or minus sign for subtracting, and we don't use the slash for division, and we don't use the asterisk for multiplication. And so to make this follow that criteria, instead of subtracting negative b, I'm going to add a negative b here. This is the implementation for addition and subtraction, but for multiplication division, this is going to be a little trickier. You're going to have to figure out, how do I multiply two numbers, only adding numbers? Okay, so this is where I'm going to leave us for now. The next video is going to be my solution to the project Everything is Addition. So if you get stuck and you just can't figure it out, you can follow along in that video and pause it when you need to, and I'll be showing my solution to it there. So I'll see you in the next one.